and get started. So as I mentioned, first I'm going to cover a little bit of an introduction to sheet metal, what it is, why you'd use it, before talking about the individual features, what you can do with them, and how that'll benefit your designs in Creo. And then I'll move on to a demonstration and a Q&A. All right, so a tiny bit about me. I'm a technical specialist at Boundary Systems. I've been working there for about 2 years. And before that, I was in the engineering field for about 7 years. And I worked with various different CAD software, mostly SolidWorks, but AutoCAD a little bit as well. And there's my email too, if anybody would like to reach out. Very brief introduction to Boundary Systems as well. We are mostly a PTC partner. We work with nearly all of the different PTC software. That will include licensing, teaching classes, data management through Windchill, consulting, and CAD work, mostly with simulation, and additionally product development. So we can look at your products, see which tools might be best for the job. We've received numerous awards. The few that I'm going to mention are PTC Platinum Partner and PTC Authorized and Certified Training Partner. Going a little bit more in depth with that, COVID has shut down training, not completely, but it's slowed down a bit. We've done a lot to prepare for the inevitable surge of training that comes after that. After this dies down a bit, we are open for business. We have remote classes in addition to opening up in-person classes as well. In addition to the various PTC software that we have access to and that we specialize in, we also work with several other companies such as Moldex 3D, eTraj, and Keyshot that are separate from Creo, but we think fulfill a specific niche that PTC products do not cover. So we have experts in the listed software, including some others that we use as part of our repertoire to solve whatever problems that you all might encounter. All right, so moving on to sheet metal. First, I'm going to talk a little bit about what sheet metal is. So in the real world, a piece of sheet metal is going to be a constant thickness piece of metal, and generally you're going to make a single part out of one piece of constant thickness material. That's going to be done with extruded cuts, with punch forms. So by creating an indentation with another punch, a manufacturing material there, or a manufacturing tool rather. And additionally, you'll often make a lot of bends in this sheet metal part to create something much more complex than the flat sheet that you started with. So that's kind of what sheet metal is in real life. In Creo, it follows a very similar definition. So in Creo, a sheet metal part is going to be a constant thickness, single material part. And with that constant thickness, you're able to create a primary wall, which will kind of be the base of your part. And from there, you can create secondary walls, you can create bends, you can create cuts, you can create punch forms. So the main benefits of using sheet metal in Creo, I think there are numerous, but I can sum it up into two main groups. So first of all, if you are working with sheet metal in the real world, you have a lot of things that you have to consider that are specific to sheet metal. The first I already mentioned a little bit, but generally you're going to be using with one sheet of constant thickness material. As a result, a lot of the tools that are available in Creo Parametric are not going to apply to sheet metal. as a result of that, we have some specific tools that make creating features in sheet metal much, much easier. So once you have that primary wall constructed, it's very, very easy to create secondary walls, namely flats and flanges, from that primary wall. And you can do this in a much easier way than if you had to create a second extrude and do this as you would in a normal Creo part. So in that sense, it's much more specialized for those real world situations you'll run in when you're using a constant thickness piece of material, like a sheet of sheet metal. So that's the number one reason. The features and user interface that you'll encounter in Creo sheet metal design is going to be much easier and much more specific for the actual operations you'll use in the real world. And the second reason, which I think is more important and more of a time-saving and effort-saving feature, is the fact that Creo is going to be doing a lot of calculations that are not going to be visible on the surface level UI of Creo. What I mean by that, when you create a sheet metal part, you're going to assign a material for your constant thickness sheets. And Creo is going to use all sorts of formulas whenever you create any sort of feature, such as a punch form or a bend. Creo is going to do all sorts of calculations to figure out what that material and model is actually going to look like. An example of that is developed length. So when you do these bends, let's say you start with 200 units of material, you're actually going to be changing that unit length when you go through these sheet metal operations. If any of you have used sheet metal in the real world, you may have noticed that that the dimensions you start with and your final dimensions are not going to be the exact same. The reason for that is that every bend is not going to be perfect. You're not going to have a perfect 60-degree angle that preserves all of the material in exactly the same way. Any of these bends are going to be done along a radius, and that material is going to be stretched, and it's going to deform in very predictable ways. In the olden days, these calculations would be done with various formulas, and they would all have to be done by hand, or of course just by trial and error, by performing these sorts of operations, kind of guessing a distance and seeing what happens. By using Creo's sheet metaling tool, you're able to get much, much more exact without actually trying out these operations. Creo comes with many preloaded materials and formulas so that any of these operations that you do are going to be accurate to the real world. And of course, you can use that information to figure out how much material you have to start with that final design in mind. So elaborating on that a little bit, there's a feature that I'm going to show called Flat Pattern Preview. What this allows you to do is see in a separate window exactly how that flat piece of sheet metal that you'll start with is going to need to look to create your final parts. So that'll include the length and width outside bounding dimensions. That'll essentially tell you how much of a sheet that you're going to need to start with. And additionally, it'll come with dotted lines that will show where each bend and feature is going to be added. Going one step further from that, the detailing step of any part modeling process, we have some specific features incorporated into there that are more applicable to sheet metal in the real world. First, you can add drawings of either your flat or completely formed state. Bend order tables is a very important one. Oftentimes, your sheet metal part will have to be created in a certain sequence. As I said, if you're starting with one big sheet of metal to create a very complex part, oftentimes the bends will follow a sequential order. and this can all be conveyed in your detailing using these various tools such as bend order tables. All right, so I believe that covers a pretty good intro of why you'd want to use sheet metal, what it is, and what it exactly means in Creo. So next, I'm just going to cover the basic tools that you'll be using. The first thing you need to do if you're going to create a sheet metal part is either create a new part or convert an existing part. So a little bit about that process. A sheet metal part in Creo is actually categorized separately from a normal part. They will both be part files, but you have access to these different operations and different features when you're editing a sheet metal part rather than a normal part. So the two ways to do this: number one, you can create a completely new part and designate it as sheet metal right from the start. This is the approach I would personally take probably 9 out of 10 times. If you know that you're going to be starting completely from scratch and you know that your part is going to be sheet metal, then I would recommend creating a new sheet metal part right from scratch and just thinking in that sort of mindset from the start. The other way you can go about this is you can actually convert a solid part into sheet metal. You will have to designate a primary wall, and that primary wall does need to have a constant thickness, but you are able to convert existing non-sheet metal parts into sheet metal. As I said, I think usually the way to go, especially if you're starting from scratch, is to create a new sheet metal part. But if you are going off of something that's already created in Creo, either by one of your colleagues or by yourself for a different project, different parts, and you simply want to be able to model that using these sheet metal tools, you do always have the option to convert a part to sheet metal, and I will show you how to do that. So as I mentioned, you do need to have a primary wall in a sheet metal part. This is going to be a wall that's essentially used as the reference location for all of your other walls. So if you imagine this big sheet of sheet metal that is completely unmodified, it's just a big flat sheet of constant thickness. You can imagine laying that flat on a table and then performing all sorts of bends while one of those, while one solid edge or rather solid surface of that stays on the table, kind of stays flat. So that's kind of how I like to think of a primary wall. It's essentially a location reference that all of your bends and various operations are going to be in reference to. So once you have that primary wall, you can make several secondary walls, really as many as you want. These come in the form of primarily flat and flange. These are going to be very similar features that really only are different in the references you select to create them. But essentially, they allow you to create walls that extend out from that initial wall at whatever angle and with whatever amount of material that you may want. There are a couple of operations you can do on these secondary walls. You can trim them, you can extend them, and you can add corner relief as well. So corner relief essentially are going to be little cutouts that are created at each corner where a bend is being performed. This can be structural to add additional strength to your bends. It can be functional in order to make your material fit together better. Or I suppose it can be cosmetic a little bit as well. These are completely customizable. There are several pre-loaded types of corner reliefs that you have the option of choosing. And additionally, you can create your own, modify the dimensions of each of these types of relief as well. Lastly, after you create your primary and secondary walls, you can go ahead and add specific features to your sheet metal parts. So these are going to come in the form of bends, which I believe is pretty self-explanatory, but it allows you to perform a bend on one of your existing walls You also have forms, cuts, and patterns. So cuts are going to be exactly what they sound like, just like in Creo Parametric normal part modeling. If you create an extruded cut and remove material, that's exactly how that cut feature is going to work in sheet metal as well. Forms are a little bit different. These are going to be, they're not going to remove all of the material. Instead, they're actually going to model what it would be like to add a punch or a press to your sheet metal parts. This is often going to be used in manufacturing for strength or stability, or in order to just get your sheet metal part to fit into your initial part if you have any kind of bolts or connectors that you're going to be adding. These are once again going to be completely customizable, and that's actually going to be in the form of part files. So you can create your own forms by creating the 3D model of the punch itself and saving it as a part file. You can then load in that part file into your sheet metal parts and essentially simulate what it would be like to add that press to your sheet metal. Once again, all of the calculations relating to material, any kind of strength and stress inside of that material if you go the simulation routes, and all the different radii that are going to go into performing these bends. These are all included in the calculations when you create a punch form. All right, next I'm going to briefly cover the new features that come in Creo 7, specifically relating to sheet metal. First is multi-body design. Now this is not specific to sheet metal, but it does have implications across all of Creo, including sheet metal. Multi-body design is a very, very powerful tool that allows you to create multiple bodies in a single part. Now you may remember that I mentioned earlier, sheet metal parts often come from one continuous solid thickness piece of metal. Using multi-body design, you are actually able to add additional bodies. That can mean additional sheet metal parts, and you can then incorporate those into a single part file, rather than having to assemble them through the assembly interface. Additionally, we have a rather small change that I think has a pretty large range of uses, specifically for geometry features such as punch forms. You now have the option to extend that feature to a cut edge. So if you see the pictures on the left there, or rather on the right, sheet metal used to work no matter what, like the picture on the left shows. But we now have the option in Creo 7 to actually extend that feature all the way to the flat surface. And the calculations there, which would require more material to make that work, those are all going to be done in Creo and incorporated into your final design. So if you ever want to create a feature that borders an edge that includes a flat surface, then this is now going to be possible and doable in Creo. All right, so I'm going to move on to a demonstration. All right, so here I am in Creo Parametric 7.0. And we can see that I have a very large assembly here. This assembly contains multiple subassemblies, some individual parts, and many of those parts are going to be sheet metal and many are going to be not. They're all incorporated together into this very large assembly. So for this example specifically, I'm going to be working on a small part of the chassis. So I can select chassis here, and we can see that this is going to be a very large assembly, not sheet metal. And if I select this subassembly called starting, this is actually going to be a sheet metal part that's incorporated into here. So I already have this starting subassembly open. If I just click over here, we'll see that this is the sheet metal parts that is incorporated into that design. The first thing you might notice is that if you look at the model tree, we'll see that we have specific sheet metal features that you're not going to find in your normal part interface. These mostly include flat walls, which are going to be secondary walls extending from that first wall. We also have extruded cuts, which, as I mentioned, are going to work very similarly to Creo. And we have some form punches as well. All right. So I'm actually going to move to a different sheet metal part. This sheet metal part is a little bit simpler, and I chose it because I think it's very easy to demonstrate some of the concepts that I just talked about in my presentation. So this sheet metal part, first of all, actually started out as a non-sheet metal part. We can tell that because an initial extrude was created, and then we can see in the model tree here that that extrude was converted into my first primary wall. This was done by converting to a sheet metal part, and the way you're going to do that is through this operations dropdown. You'll see at the very bottom, I'm already a sheet metal part right now, but I do have the option to convert to solid parts. And if I'm working with a solid part, I can convert it in the same way to sheet metal. And when I do that, my ribbon will change completely. Now, if I wanted to make a new sheet metal part, just to briefly demonstrate that, it's really, really easy. You're just going to go to File, New Part, and you have the option to set this subtype right away. So I could just go ahead and create a sheet metal part, and I would be prompted to create my first primary wall, and my UI would look just like it does now. All right, so first thing I'm going to do is just create a flat. So this is going to be a secondary wall. If I click this flat tool, I'll be prompted to select a reference. Looks like I have a little bit of a load time, so bear with me. There we go. We'll see that I'll have to place it somewhere. I'm just going to select this edge on the edge of one of my existing secondary walls, and we can see that this immediately autofills to kind of guess how I want this to look. You can see on the right side, it actually follows that existing adjacent edge, and we have a lot of different dimensions that we can set here. You may notice that compared to creating an extrude and then maybe a round feature, making sure these are constant thickness, it's much easier to do something like that in sheet metal, just a couple clicks. Now I'm just going to drag this a little bit to make sure there's no overlap there. I'm also going to change this angle. Dragging is probably not the best route, so I'm just going to just change this manually to 45 degrees. And the next thing I'm going to do is talk about corner relief. So as I mentioned, whenever you do one of these operations, you can add corner relief to your secondary wall. So this will be done in the relief tab here. So I'm going to click corner relief, and we can see in the picture right below where I selected, you can change the thickness. So I'm going to go ahead and change this to 2 times thickness. And just to clarify, that's going to be the thickness of my sheet metal, of my constant thickness sheet of metal, essentially. And if you remember, that's kind of one of the requirements for a sheet metal part. It will have constant thickness, so you can always be sure that that value is not going to change. So if we just zoom in on this corner relief that I just added, we can see that it looks like a circle, just like we'd expect. And you can see that it fits together well. Creo does the calculations correctly for various intersections and whatever material you're working with in order to make sure that relief works. All right. Next, I'm just going to show one of the operations you can do on a secondary wall. So I'm actually just going to extend this wall right here. We can see the various editing options. So these are going to be kind of the functions you can perform after you create these primary and secondary walls. So I'm going to be showing extend here. So if I go to references, I'm going to have to select a edge right here. From here, I have a couple options. I can just drag manually, or in my case, I want this wall to extend to be even with the rest of my part. So I'm just going to align it with this plane right here. And we can see that that looks much better now. All right, so now what I'm going to do, I'm going to go back to this initial part. So you'll notice this is the one that was incorporated in that snowmobile. And I'm going to undertake just some various operations with removing material and adding punch forms. So first, I'm just going to point out there are several sketches that I created here beforehand. The first is the sketch that you see highlighted in green on the screen right now. I'm going to use this sketch to remove material via extruded cuts. So you'll notice if I click this, I have essentially the same options that I had in Creo. As I mentioned, the extruded cut feature is very, very similar to a remove material extrude that you encounter when creating a normal part or even a normal assembly in Creo. So I'm able to select through all, for example, make sure this is going through all my material infinitely in both directions. And I can click OK. So rather simple to do that. I'm just going to go ahead and actually suppress that for now. And I'm going to show you all how to create punch forms. All right. So punch forms are actually going to work exactly like creating a hole in Creo. So in that sense, I'm going to click on a surface that I want to insert my punch form, and you'll see that once again I have these dimension draggers, just like if I was creating a hole. So I have some options for how I place this. Linear is the option that's available by default, where you'll see these draggers that we're going to set to two perpendicular linear references. So if I just go ahead and drag and drop these to, let's say, the top and the right edges here, I'll be able to set each of the dimensions to place this exactly where I want. So for now, I'm going to make this 19 and this 70. I'm going to set it over there in that corner, and we can see the preview geometry of what this is going to look like. All right. So now once we have this created, we can go ahead and pattern it, just like other features that you would find in Creo. So I can do that either by this editing dropdown like I showed before, or if I right-click in the quick access toolbar, I can see I have the option to either pattern or mirror as well. So I'm going to go with pattern here. Of course, I could pattern this in any of the normal ways. I could pattern it in a single direction. I could pattern it radially. For this example, I'm actually going to do a fill pattern. So one of my additional sketches down here, sketch 4, you can see bounded by that green line. And I'm going to use this to actually fill that entire area with equally spaced punch forms. So you can see I can set the spacing here to be as spaced out or as not spaced out as I would like. So I'm just going to switch that to 30, which actually allows an extra punch form in each of these rows to be created. We can see that when I click OK, it's going to go ahead and regenerate and create all of those punch forms. So now what I'm going to do, I'm going to go back to this initial pattern member. Worth noting that in Creo 7, I could actually edit any of the pattern members and it would be updated across my entire pattern. But being someone who's used previous versions, I still usually pick the first pattern member. So, cancel. I'm actually going to go ahead and delete this pattern because what I want to do is use a different shape, and I'm going to show how that looks. So once again, I'm going to create a punch form here, select that surface, but this time I'm going to click Open Offset Form in millimeters, which is actually the same shape. It's just a little bit bigger. It's deemed to be a certain size in millimeters, which is fine. It's just going to look bigger on my model, which is set in inches. So once again, I'm going to set the various position references here. We can see that I get a nice preview of what this is going to look like. I'm just going to change these numbers around a tiny bit and then go ahead and complete. Now, the reason I'm doing this is I want to show the new feature that we have available in Creo 7. So what happens if this punch form is extended over the edge of your sheet metal part? So once again, I'm going to go ahead and pattern this. And I'm going to do the same thing. I'm going to make a fill pattern. Since this is a bigger punch form, these same parameters are going to potentially cause me some problems. So we're going to see what happens there when I bump this up just a little bit. Okay. There we go. So we can see that this works just fine. And these punch forms are extending to the edge of my sheet metal. But we can see that these edges where it intersects are going to be curved. And they're actually going to be calculated based on starting with a flat sheet of sheet metal. So I think this is just a really, really good example of first of all, seeing how these calculations are done, how Creo is looking at this and calculating how this material is going to bend, so the directions and dimensions in every direction you're going to encounter. The second reason I want to show this, so here if we go into my pattern and I'm going to edit this this initial form, I want to show this new feature in Creo 7. So if I go to options, we can see this little checkbox for trim edges of a sheared form. This will essentially extend any kind of punch form that intersects with an edge to be a flat feature and to blend seamlessly with your existing edge, with your existing flat edge. So if I click OK now, we're just going to see how this regenerates a little differently. It's now going to show up as completely flat when we look at it from the right angle, completely flat in relation to that edge. And of course, there are going to be implications for how our initial sheet is going to look, how our initial part, and we can actually see that using the flat pattern preview, which I'm going to show next. So for this, I'm just going to go back to our initial part because it's a bit easier to conceptualize how this would look if it was all flattened out. So the way we're going to do that is just this flat pattern preview here in the InGraphics toolbar. So if I select this, I do have to designate a fixed geometry. If you remember that example of laying something flat on a table and then bending it upward while one surface of that stays on the table, that's how I like to imagine this. So I'm going to select this surface as my fixed flat reference and click OK. So in just a second, this is going to come up with a flat pattern. Essentially, it's thinking right now, and if we see where I drag this over, we can see the flat pattern that it's going to create. Additionally, you can see that this additional edge, or rather this additional secondary wall I created overlapping geometry. So Creo is telling me that I actually cannot generate what I've created here using a flat sheet of metal. We're going to have an overlap here that's not going to quite work out. Now, if I click these bounding dimensions and zoom out just a little bit, we can see that it gives me the dimensions, the total dimensions of the sheet I would need to create this. And as I mentioned, that will include all the calculations of the radius of each bend, the extra material that is the extra length that is going to add or take away depending on what you're doing. And also it considers the material that we're actually using. So this is going to vary depending on your material properties, and all of that is going to be calculated automatically. The last thing to mention, this flat pattern preview, by default, it's going to be locked into your Creo window, which for me, using 2 monitors, it can be a bit annoying. So there is a configuration option to unlock the accessory window. So I believe it's just called accessory window, and you can mark that as undocked rather than docked. And that allows you to drag this over to a second monitor. So any changes you make on your sheet metal part, you can see what it looks like in your flat pattern. So for example, when I created that initial wall, I could see right away when I created it that when that pattern is all flattened out, there's going to be a contradiction there. So now what I'm going to do, just going to select this wall, edit definition real quick, deal with a bit of a load time, and then I'm just going to drag this over to the left, and we're going to see what happens when there's no overlap. All right, so now if I enable flat pattern preview here, I'm going to do that same fixed surface. By the way, just a little mention, it's not usual that it takes this long. It's just a problem I'm having with my Creo today. Load times are usually pretty much instantaneous, but here we can see the flat pattern now. There's no overlap. We can see exactly how it's going to need to be dimensioned to create it, and additionally, we can see dotted lines that indicate each bend that's going to be performed. All right, so that wraps up what I am covering today for Creo Sheetmetal. I'm going to open it up to questions now, and I'm going to give everybody a couple minutes to get those submitted in, and then I'll go ahead and answer questions. In the meantime, here on the screen, you can see my name and email. Additionally, we have sales questions. We have our sales email there. And I'd like to highlight our YouTube channel, which will have this webinar on it in just a couple days. And additionally, all of the previous webinars we've done. It's a great resource. You can just Google Boundary Systems YouTube, and I think that's the easiest way to pull it up, and you'll find hopefully a wealth of information there that can help you with whatever you're trying to do in Creo. So I'll give everybody a second for questions, and I will then answer that. All right, so first question is regarding extruded cut feature. The question was, is it specific to Creo 7? So the answer is yes. I believe it's specific. It's new to Creo 7. It may be new to Creo 6, but you are correct that they did kind of change the name of and the appearance of that extruded cut. It works as far as I'm aware. It's the exact same as the previous feature of extrude or remove material, what it was called before. But yes, that is actually new, and that's something I've taken note of. Let's see. One of the questions is sheet metal is not always constant thickness. So I believe there are operations. Again, I'm not actually the most experienced with the manufacturing aspect of this, but I am aware that there are ways to roll out sheet metal so that it's able to get longer in certain directions and not a constant thickness. Regarding those kind of functions, it would be calculated again completely in Creo relating to the specific material. As far as if anybody has specific questions on those, I would need to look into exactly how that works and the potential uses of that. Can you flatten formed parts as you can with other sheet metal features? Not sure I know entirely what you mean there. If you mean a flat pattern preview, then the answer is yes. If it can be flattened by Creo, so sometimes it will tell you that this cannot be flattened. That may be due to kind of a strange feature that you've converted to sheet metal, or it may be due to an overlap like we encountered there in my example. So it will not always work, and it'll tell you if it doesn't work. It'll tell you which features cannot be flattened. But as far as creating a flat pattern preview, you can always click that and always try in Creo, and the engine will try and get that back to you if it sees it as possible. Next, there's a bend in the snowmobile part that looks interesting. Looks like neither a bend or a form. It was to the left of the form feature I was patterning in. How is a feature like that made? So let's see, I'm gonna take a look at that and just make sure I know what we're talking about. All right, so I believe we're talking about this feature right here. This I believe is what's being referenced. So this is actually a punch form. So if I go into edit definition here, let's see, okay. I may have to look into exactly how that was created and get back to you. That is really an interesting one. And I assume it's a punch form that's loaded from a custom file. But you're right, that is really, really interesting and really practical. And I'll need to look into that and get back to you with exactly how that is created. But that is a very good question. All right, let's see. So next question is relating to this part specifically, if I can flatten it. So the answer is yes. However, so I'll show what happens. But this part down here, this area, this oblong shape that's created, for some reason this isn't flattening properly, which is why I didn't show it. Not entirely sure why, but I can let you know what happens when we try and flatten this. So in just a second, this is going to pull up. Here we go. So we can see that this model is not fully flattened. So it was able to do the flatten on the top part of this sheet metal part, but it ran into some non-specific problem. with this bottom geometry. So in this case, this is just an example of the flat pattern not working. With exactly why that didn't work, I'm not entirely sure without recreating the features one at a time. But I do know that it's related to this bottom edge right here. That is that's not quite working. So I just got a question slash pointer relating to this feature. This is actually a gusset made in the same way as a form feature, according to one of the customers, and the interface is just still, so if I try and edit definition of this, this interface is one of the few that has not been updated from Creo Engineer. So other examples of that will be adding additional models to an assembly. You may remember that you get kind of one of these archaic looking menus. So this feature was created in that way, and I'm not entirely sure how that's done, but that's at least that at least should point you in the right direction. There we go. All right, let's see. I think we had one more question. Is there a weld tool for connecting edges that meet each other? So I know there's a whole bunch of weld tools in Creo. This is going to be my colleague Sean's area. So I'm going to put him in contact with you, Tino, to discuss the various welding tools that you have available. I know that these tools are going to be a little bit separate, so I'm just going to put you in contact with Sean to get that figured out. All right, I believe that's all. Oh, we do have one last question actually. Can you use flexible modeling in the sheet metal module? The answer to this is definitely yes. This is something I didn't quite mention because I just didn't get to it. But flexible modeling is very, very useful for sheet metal. The reason is that, as you may know, you can bring in a lot of different types of files into Creo besides just kind of neutral file formats. An example that I'm actually going to show really quick, just while we have time, I'm just going to quickly load a SolidWorks assembly into this sheet metal part. But while I do that, I'm just going to talk a little bit about flexible modeling. This is a very, very powerful tool for sheet metal. The reason being that there's not usually as much complexity in a sheet metal part or assembly as there is in a non-sheet metal part or assembly. And what that means is that you are able to do most of the edits that you would do normally in a flexible modeling environment. So for example, if you bring in a sheet metal part, for example, flexible modeling is going to be a very, very good tool to use that you're able to customize your sheet metal file with. So the answer to that question is yes, definitely. I think sheet metal is one of the best uses of flexible modeling because you're able to really modify many parts of your model, including punch forms, including remove material. This can all be edited with flexible modeling, yes. All right, so this is the last thing I'm going to show. It's not very insightful probably to many of you, but I'm just going to bring in a sheet metal part here, or rather, I'm sorry, a SolidWorks assembly. We can show how that's integrated into this assembly and what that looks like. So you'll notice type here in the type of file that we're going to be bringing in. And I can just change that to SolidWorks if my Creo cooperates. Just for a little background, it's my antivirus that's causing this problem with Creo load times. So sorry about that, but if you were to do any of this on your own, you would not run into these problems. So I have a SolidWorks assembly here, and I can just bring this in now in the same way that I would any other part. So if I do default constraint, aligns these coordinate systems. Yeah, it's pretty seamless. If we look at the model tree, we will notice that you don't have a full list of features. So for example, this sheet metal part right here, made in SolidWorks, you're able to see the geometry, but each individual feature, such as the punch forms, for example, are not going to be shown specifically in the model tree. So that's, as I mentioned, a really great use of flexible modeling. The sheet metal parts are usually, as I said, very compatible with flexible modeling. For example, if I was to edit this hole, I could, for example, extend it to the end of this hole to create one large cavity and make rather large edits without actually having any of those features in the model tree. So I hope that answered your question, but yes, it's definitely flexible modeling. Okay, that covers it for our webinar today. Thank you everyone for attending, and I look forward to the next time I'll be speaking with you. Hope you all have a great afternoon, and thank you very much.